Okay, so let's talk about another type of passive transport. This is called facilitated diffusion. So, facilitated diffusion is passive, which means that it doesn't require energy, just like regular diffusion. But facilitated diffusion means that there must be some type of protein that is facilitating or helping the diffusion to occur. Okay, so for example, if we're looking at let's say if we're looking at something that's small uh, and nonpolar, these types of things can easily diffuse across the membrane by themselves. But if we're looking at something that's polar, okay, polar molecules cannot cross through the cell membrane because the cell membrane has these large nonpolar regions. So polar molecules have a tough time going through this. I mean, they can, it's just hard. Okay, they can't go through very easily, especially if they're very polar, like ions. So instead, they have to go through a membrane protein and they have to do something called facilitated diffusion. So facilitated diffusion does not require energy because the particles are flowing where they want to flow. They are just spreading out, just like normal diffusion. The only difference is they can't go through the membrane by themselves like normal diffusion. They have to go through a transport protein, okay? And that's facilitated diffusion. So this is the transport protein right here, and specific molecules, like for example, this one fits with this transport protein. It's going down its concentration gradient. It's spreading out just like it wants to, but it can't go through the membrane, so it's going through this transport protein here. Okay, so transport proteins help specific substances. Like each transport protein might only transport one type of molecule. Okay, specific substances diffuse across the membrane down their concentration gradient, so there's no input of energy required. We're not using ATP. These particles are just flowing down their concentration gradient through this channel protein here. Uh, Water moves through the membrane a little bit on its own, but most of our water goes through a transport protein that's called an aquaporin. These were just discovered in like 2003, so not that long ago. But most of our water is transported through our cell membrane through the use of an aquaporin, which is a type of facilitated diffusion. If you want to read 5.7 here, it's talking about Dr. Peter Auger, who got the Nobel Prize for discovering aquaporins. It's pretty cool. Basically, he was looking at blood and something called the RH protein. Um, I'm not going to go too much into it because it's not on the AP test, but basically, you can look at his experiment if you're curious about how he discovered these aquaporins. But I'm going to move on to the next part, which is active transport. So, active transport, as opposed to passive transport, active transport requires energy. So, in active transport, a cell must use energy, which is ATP, to move something against its concentration gradient. So, do you remember back here how I said the particles, they want to go down here, they want to spread out because in nature, particles like to spread out. Remember all the way back to here. Okay, particles want to spread out. Particles want to diffuse. Okay, they want to diffuse. This is just something that happens in nature. But with active transport, we are pushing something where it doesn't want to go. We are fighting against the natural physics. To do this, you can fight against physics, just like you can push a ball up a hill, but to do so, you must use energy. Okay, so by using energy, we can push these particles and molecules against their concentration gradient. This is called active transport. So we're going to look at a few different stages of active transport. So the first thing that's happening here is we have this transport protein, and we have these particles that we want to move against their concentration gradient. Well, by using ATP, we can change the shape of this protein to release these particles where they don't want to go. Because remember, these particles, where do you think they want to go? They actually want to go into the cell, not out of the cell. But by using energy, we can force them to go out of the cell, okay, where they don't want to go. We can push them up the hill. We can push them against their concentration gradient through the use of ATP. And we actually do this all the time in our bodies. Okay, really, really common. It also happens a lot in photosynthesis.